So this is Chad Woolley with GitLab, and I wanted to catch everyone up on the status of the remote development architectural spike. And I've been working on this for the past several days over the holidays, and I wanted to demo where it's currently standing and give some background information. And that should hopefully set us up for the next steps of being able to split up this work and parallelize everything else that we have to do. The spike is in a pretty good spot, and I think close to being considered successful in terms of proving out the architecture. So I'll start by not burying the lead. I'll give a demo of what we currently have, which is a working state reconciliation of the state of workstations in the Rails database and workspaces in the Rails database and in the Kubernetes cluster via the dev workspace operator. So I'll start. I'm going to explain all of this in detail later, but I'm just going to demo it first. There's a helper script, scripts remote development, create workspace. If you run, and over here on the left, what you'll be watching for is this is going to show all of the state of the Rails of the work spaces in the Rails database. This is going to show the state of the workspaces in Kubernetes. This is a log of just the filtered out debug statements from Rails log, and this is the debug logs that we have from the agent K in the GitLab agent for Kubernetes. So let's run this create workspace script. Looks like that got a little confused, so here we go. So create workspace, and up here on the upper left we should see, yep, so you've got the state here. The desired state is running. The actual state is creation requested. You can see over here in Kubernetes, it got that request, and the phase is started, and now it's already running. It's got a URL. If you go back over here and wait for the next polling loop, it will get updated shortly. There we saw it go through. So now the desired state and the actual state have been reconciled. We have a URL. And we've got the workspace resource version. If you click in these things, they get kind of confused. So we saw that the creation worked. So let's try updating it as well. So you can see if I do a kube-control git dev workspaces, I can grab the name of this. I can't copy it from over there because that sort of messes up this little watch output. But then this helper, you can set an environment variable for the workspace name in this scripts remote development update workspace. Paste that in there and have the desired state. So this is it's currently running, so let's set it to stopped. And these match the official phases that are sent over from the dev workspace operator. We don't really have a state machine for now. We might at some point in the future, but we're just going directly off of the state that gets sent over for each workspace. So if we click that, we can see if we look over here, this should change to desired state stopped. There it is. And it stopped almost immediately. You can see on that poll over here on the Kubernetes side. And then that actual state got echoed back here. So now it is in the stopped state. And we could even, let's go ahead and create a second one. There's a second workspace. And then we should see two of them show up here. Yep, there's one with a second name. Creation requested, and we see that second one show up here, waiting for deployment, waiting for editor to start, and make that window a little bit bigger. And there we go. That one is now running. And if we were to, so you see the URL is over here. If we were to click on that URL and go into it, this is just a minimal proof of concept TTYD. So we're running, can't find a group or something, whatever, the workspace is successfully running. And there's what we have. So now I'll dig into a little bit of what we're doing. So looking at the architecture here, so the rest of this architecture doc page may be out of date. We need to update it. The part I've been focusing on is all of the logic for the Rails workspace updates processing logic. This reflects what is going on here. So you can see here it's a very thin layer at the Great REST API level. The state tier is actually very thin as well. It's pretty much just taking the params and pulling them out. The Workstation infos is what we call them. That's the configs that are coming over from Kubernetes. And all of the business logic lives here in this lib layer. And that's what it's doing. Some of the bigger chunks have been pulled out into sort of loosely coupled and cohesive things, like the parsing of the actual workspace info out of the just the JSON, the raw JSON that's sent into this data object type thing. And then that's then passed around with some logic in it. The generating of the config, the desired config that we're going to end up sending back over to, well, that got big, to send back to the agent K side. That's pulled out, and this represents, the places where we're interacting with active record, where we load the workspace objects, and then where we update them again. And also, this workspace states is up to date. So these states right here are the actual ones that the dev workspace phase that are officially come over from dev workspace operator. You notice there's not a terminated one, so we'll have to figure out how to handle that. But that's okay. And the actual state, so these ones over here, the ones that are really supported, there's this one called creation requested, which represents this has been created in the Rails database, but we haven't sent it over to Kubernetes, so like it doesn't even exist there. So as soon as we get the first pull back that's with the name of this workspace, and it says we know it exists, then we have a phase of starting, and it gets automatically synced to whatever phase is sent back from the informer on the Kubernetes side. And then there's the desired state. So this is, and both of these are just properties of the workspace in the database. This is a smaller subset because this is just what I want it to reconcile to. So like you wouldn't have a desired state of starting. You either want it running or stopped. And again, in the future, we'll figure out how to deal with terminated. There's some more logic that needs to happen on the agent side for that. And then there's a special case, which is restart requested. And this isn't implemented, but it's basically that we have to, it's already running, but we want it to stop and restart again. So that will be implemented by sort of looking at some other metadata that's sent, and like if it's already running, it'll, send the config to stop it, and then once it's stopped, then it will put it back in the running state, and then automatically flip over the desired state to running and just wait for it to eventually get in running, and which it may never get to. It may stay in this failed or error state. So that's the diagrams of the code. This other stuff in here, timestamps and some of the things up here, may be outdated. We need to make another pass through this. As far as the code, if we look in here, so you can see I'm running, even though this is a spike, I tried to make it fairly disciplined and clean, and it's 100% test coverage of everything that I've written here, because the CI won't go green if it's not. You can look here. Here's the latest CI build. You can see it's completely green, no under coverage. I just pushed another little fix, so it's taking another one off. The MR, the main MR that this is for is this one, the 805 in GitLab agent. We're sort of using it to drive this. And there's two sides. There's the Rails side, which is where all of this code that I just showed you lived. And then there's a corresponding MR on the GitLab agent side, which is all of the stuff over here on the Go side. Almost all that logic lives here in worker.go. And you can see the structure like Workspace, agent info and the request payload. This is what's going from the agent over to the Rails side. And then the Workspace Rails info and the response payload. This is the structure of the things that come back. And over on the Rails side, these have all corresponding structures, right? So you can see that corresponds to the actual workspace info that's coming, and then in the processor, what we're sending back is this sort of down here, this structure that is going back to the agent K side to get parsed by Go. And the 100% coverage, you can see the specs here. There's multiple specs of different levels, like there's this state. The states are represented here. The model is, where's the EE one? Probably this one? No. This one. So this is there's a factory for Workspace, a factory about factory that lets you build things. And there's also the EE. Where's the EE one? EE, there it is. Why am I not finding you? Drill down. So, structure, EE, app, models, remote development, I'm going to PQR, models, EE, remote development. And I realized all of this stuff has to live. If one thing lives under the enterprise namespace, everything does. The services, the lib, the factories, everything, or things just, the classes cannot be found. So you see here, it's got these associations, belongs, for now it's owned by a user and a group. So like a user is the person who's using the workspace. The group, for lack of more product direction at this point, is what is the billing. And that's, groups are actually single table inheritance of namespaces, right? And then, of course, it has to be assigned to an agent, the GitLab agent for Kubernetes cluster agent. So that's all tracked, validates those associations, and then it also validates the valid desired states that we have over here. So as we saw, this matches the architecture diagram exactly. These actual states and desired states. Looking at a little bit more about the specs. So there's the state reconciliation service. The service layer is very thin here. All it does is validate that the message type we got is good. The only one that's currently supported is workspace updates. And then it pulls this workspace agent infos out of the params, and this is again corresponding exactly to this that gets sent over, an array of these in the payload from the agent K side. We parse those out and we send them to the processor. And then all of this rest of this stuff lives under the lib folder, right? EE-lib. I like to do this because then it's a really clear segregation of all of the domain logic. And on some of these, like if you look at the test for them, you can use the fast spec helper for these. And if you were to run these, they run in extremely fast, right? 3 milliseconds, as opposed to the other ones where you're working in Rails, when you don't have that fast spec, it's a lot slower. And there's also this context. So the state reconciliation, there is a spec for the service. I started with this one, and it's really testing a lot more than it needs to now that I went ahead and refactored all of the real logic to live under the lib folder. But this is still testing, and there's this pretty much just a happy path case. And there's this set of shared contexts that are shared across these multiple specs that have the representation of the YAML and sort of parameterized sort of object matter factory type things to create these various different types of YAMLs that you Workspace config YAMLs that you might receive with a different resource version or different status, as well as the dev workspace. So that is a little tour of the code there. And if you look at this processor spec, here's where most of the guts of what it is testing the various scenarios here, right? So we've got, when receiving updates, when the state matches the actual state, when it doesn't match, when the phase is not present, what drives state, when the phase is not valid, when a workspace doesn't exist, Rails doesn't know about it, but somebody manually created a workspace on the via kube control on the Kubernetes side, like we don't blow up. It just prints an error message for now. And then when this case is when we've just created a new one and Kubernetes doesn't know about it yet, so this is testing that it sends all of the right information over. And this desired config generator, like I said, is the part that builds the configs that we're sending back to Kubernetes, which will, we could pull more of this logic in here. This is sort of a big method, and but it's pulled out to a little bit of stuff. We can pull out more cohesive modules, but the one that made sense to make more decoupling cohesive now was this config generator, which is the part that is responsible for building the dev workspace operator configs and config map configs that we send over. And for now, we don't have a way. There's no GraphQL hooked up to this yet. We just sort of have the the dev file hard-coded here under the spec. It's just hard-coded to a TTYD. We can, once we hook GraphQL up, that would be like a string field or something that they could pass in, whatever the actual dev file that they wanted to provision. What's another little tour? Those scripts. Here's one thing. So there's two services. The state reconciliation service, which is all we've been looking at. It's the one that accepts the input from the Grape API call, which is just in the same internal module with all of the other Kubernetes agent stuff, like Starboard vulnerability. You don't need to look at that. It's just a standard API. But there's this create service. This is what's responsible for creating the workspace in the database initially. So this would, again, be hooked up to a GraphQL create type of action. And a little bit of business logic in here. Like we have to come up with a random name for the agent and for the namespace, or at least a unique one. So the way we come up with it on the name is workspace dash the ID of the agent, the ID of the user, and then a random 6-digit. Has to be lowercase or it gets rejected on the Kubernetes side. And then for now, there's not support for dynamic or creating namespaces on the agent side, so we just have this temporary flag to override it to be default, and it's the namespace is just gl-agent ID-the user ID, and that should be unique. Like we're assuming no user is ever going to have more than one namespace on a given agent. Again, we can change any of these business rules if we want. Looking at the scripts, so the that coverage is annoying. Then we have under scripts, remote development, we've got these 4 things. There's the watch Rails workspaces, which is, that's what this upper left one is here. It's just looping through and printing out the objects of the active record workspace objects in the database. And then there's this, and it's just a while loop that loops over it and clears it every second. There's this same sort of thing, but it does a kube control get dev workspaces, which is here. There is an option to -- watch for kube control, but it seems to get confused and like spam a bunch of stuff on the screen and not clear it. So this little helper script is a little better because it explicitly clears it. And then these are the 2 that I ran before. It's just that I ran with. You can do bin spring if you want. It'll be faster. Bin spring, Rails runner, and then run this script. You could directly execute it maybe if you want, but I always want to run it with Spring, so it'll be faster. Then it just looks up the group, the user, an agent, creates it with that. Here's a little thing where we pass this temporary flag to override it to default, and then that's what created it. And as far as the update, this fetch without a second parameter will blow up if you don't pass the workspace, if you don't have the workspace name environment variable specified. And then the desired state defaults to stopped, but that could be running. Again, it's the restart requested, not supported yet. And then we just find it, set the desired state with update with the bang to ensure that the validation of the states, the desired and actual state, are happening. And then it works. And I think that's about it. I can stop there. The next steps would be, like, as you can see, there's plenty of to-dos across here, and we need to split this work up and start parallelizing and implementing it for real. We have a good basis for the unit tests of it. It's of a level of quality that we should be able to start pulling parts of this out and making individual AMRs and getting them merged in on both the GitLab agent side and the Rails side to get to a point of parity of functionality with this, putting it behind feature flags or whatever we decide to do, and then continuing to build out the rest of the functionality that we need. Thanks a lot. Bye.